Page 448 in your textbooks. We have been solving mathematical sentences lately, but we don't call them sentences. We call them by a mathy sounding word class. We call them equations. And how can I look at a mathematical expression and know it's an equation? For instance, we did a lot of, with polynomials and stuff, and an equation there's algebra-y stuff. How can we tell by looking at something, hey, that's an equation? What's the giveaway, Michael?
The equal sign.
The equal sign. If there ain't no equal sign, it ain't an equation. If there is an equal sign, it is an equation. And the key to solving an equation, class, is to get the letter by itself. So we got to identify what is with the letter, meaning on its side of the equal sign. So you picture that equal sign like a wall. If it's on the other side, we don't really care about it. We want to simplify stuff over there, but we care about what is with the variable, what's with the letter. And how do we get rid of whatever is with the letter? What's the general rule to follow? If it's with the letter, we get rid of it by doing the opposite or inverse operation, right? If it has a negative, we put a positive. If it has a positive, we put a negative. If it's being multiplied, we divide. And if it's being divided, we multiply. Right, so following that basic rule of thumb should help us as we solve these equations. Your homework was on page 448. You did the little homework section there at the bottom. I use the term little loosely. And good, and okay, that's old. Oh, okay, you're throwing me off here because of the way you...
Yeah, I did it like down.
Yeah, now what about the 15 to 22 part, though?
Yeah,
Hey, Michael, hush. Hush you up with him so he's not lonely. You just missed the last one. All right, let's take a look at these together. Number one, what did you get for your answer, Joel? Negative 21. We had to multiply the 3 because it was being divided. Number 2, what did you get for your answer, Michael?
4.
4. We had to divide the 13 because it was being multiplied. Number 3, what did you get for your answer, Ben?
0.
Okay, careful, not 0. I think what you did, Ben, was you simplified the right-hand side. 30 negative 70, and that gave you...
40.
Should have been negative 40. Now, here's the kicker. How do I get rid of this 40 to get the y by itself?
Divide.
Divide. But when you divide 40 by 40, that's not 0. It does cancel here, but it's not a 0y, it's a 1y. We just don't write the 1 because we're lazy. But over here, it's not 0, it's 1. And since we should have had the negative, should have had negative 1. But I could see where you'd cancel and get the 0. So a word of caution there. Number 4, what did you get on that one, Corey?
100.
Well, I mean, you should have simplified to get 11b equals 110, but we still have one more step to go. We got to get that b by itself, Corey.
10.
What do we do to get the b by itself?
Divided.
Divide what?
11.
11 from both sides, and that'll give us our answer b equals 10. There we go. Let's see, number 5. What did you get, Bryson? If you can find it on that paper.
B equals negative 5.
Negative 5, excellent job. Remember that negative 1 to the 5th power. Well, negative 1 to the 5th power means we have how many negative 1s, class? 5 of them, which means we have how many negatives? 5, right? And an odd number of negatives gives us a negative. Even number of negatives would give us the positive, but an odd number of negatives gives us the negative. And then 1 times 1 times 1 times 1 times 1, class, equals 1. So we just get negative 1. And then Bryson multiplied the 5 to both sides to cancel this division of a 5. And that's where he got his negative 5 answer. Great job on that one. Number 6. 7/3. What do we do, Griffin, to get rid of that fraction that's being multiplied by the W?
Multiply it by 3/7.
Multiply by the reciprocal, 3/7. That'll cancel it away. Just make sure we do the same thing on the other side. What did you get for your answer to number 6?
W equals 18.
Oh, so close, so close. And I think you multiplied the 3/7 just fine. I think you just lost the negative. I think you even canceled the 7 and 42 to get a 1 and 6 and just missed seeing that negative there, negative 18. Should have been our answer on number 6. Number 7, Kirsten, what'd you get?
24.
24 is correct. Number 8, what did you get, Jalen?
24.
Positive 24, also correct. We know that the 8 times 9, or negative 8 times 9 is going to be a negative 72. Class, if both sides are negative, what did I say we could do? Just cancel the negatives, right? Technically, you could divide both sides by negative 3 if you wanted to. But why? Why even mess with that? Both are negative, just knock off the negatives. Now it just makes it that one less thing to think about. And 72 divided by 3 is that 24. Good job. Number 9, what did you get, Elaine?
Negative 2.
Negative 2, excellent job. Number 10, what did you have, Luciana?
10.
On number 10?
Oh, wait, no, 4.
Positive 4 is correct. Number 11, Joel, what did you get? This one's tricky.
0.
0, you did not fall for it. You did not mess that up. Great job. Number 12, let's go to Michael. What you got?
Negative 3. Actually, positive 3.
It is a positive 3. I think you correctly combined your negative 48 and your positive 9 to get a negative 39. And then, is it N, right? Yeah. And then just remember, we canceled those two negatives to get positive. Now just divide the 13. There's our N equals 3. Number 13, what did you get, Ben?
9.
Okay. What do we have to do to get the t by itself here on 13?
Multiply.
By the
2 over 3.
Good. Multiply by 2 over 3. Multiply by the reciprocal so we can cancel away 3's and 2's in one step, and now the t is by itself. That means I got to multiply the other side by a 2 and a 3 also, or 2/3 also. Let's put that over 1. 18 and 3 are going to cancel.
6.
And then we got to multiply the 6 times 2 to get
12.
12 for our answer there. And then let's finish it out. Number 14, Bryson, what did you get for your answer?
I got 27.
Let's take a look at this one. We had a negative 4/9 s, and this was the one I think I wanted to show anyway. Let's simplify the 5 plus 23 real quick.
27.
5 plus 23?
Oh, 28.
28, there we go. All right, so now the question comes, Bryson, how do I get the s by itself?
You put 9/4.
Well, but not 9/4, because that would cancel the 9's and the 4's, but I need something to cancel the negative also.
Another negative.
A negative 9/4, good. So that way when we multiply the reciprocal, 9's cancel, 4's cancel, negatives cancel, s is by itself. But class, what we do to one side? So I'm going to multiply the other side by a negative 9/4 also. Let's go ahead and put, Bryson, this 28 over 1, and that way the 28 and 4 cancel.
So
And of course 1. And now 7 times negative 9.
negative 63.
Negative 63. Should have been our answer there. Was anyone perfect on 1 through 14? These were a little harder than the old ones we were doing the last lesson. A couple of you? Anyone just missed 1 or 2? Just missed 1 or 2. Okay? Any questions on any of the ones we missed? Joel, and then Luciana will come to you. Joel, which one?
9.
Number 9. Yeah, so we got the 14x equals, and it says negative 112 fourths. You could think of that as a fraction, Joel. I prefer to think of this as division. Negative 112 divided by 4. So what we have, Joel, is we have a negative divided by a positive. Gives us a negative, because the signs are different. 4 goes into 11 how many times?
1.
Twice, with how many left?
3 left.
And then 4 goes into 32 how many times? 8. So that gets it down to 14x equals negative 28. Now we're ready to get the x by itself. Now what do we do?
You divide 14.
From both sides, and that's where we'll get the x equals. Again, negative divided by positive, negative, and there's the negative 2. All right, Lucian?
Can you do number 2?
Number 2, yeah, it's just a straightforward division. It's just we didn't memorize our 13 times tables when we were kids. So when we divide away the 13 from both sides, it's just a matter of, can 52 divide by 13? I don't know. Let's see here. I know it's not going to be 5, so maybe we try 4. 4 times 3 is 12. Hey, look at that. It's 4. Who knew? You know, so yeah, we didn't memorize 4 times 13 equals 52. You just have to work it out and see what happens. Good question. Good. Other questions, comments? All right, let's take a look at numbers 15 and 16. And these are problems very similar to what we were doing earlier, It just gives us equations that involve multiplication now. But the basic process does not change. Read number 15 for us, if you would, Corey.
If 9 times a number is the sum of 8 and 19, what is the number?
All right, so they want us to solve, Corey, for some number, right? But we don't know what it is, so we're going to represent it with a letter or a variable. What letter would you like to use, Corey?
Y.
Y. Okay, because that's what you look at the problem and that's just like Y. All right, so anyway, we're going to represent the number with the letter Y. So when it says 9 times a number, if the number is Y, we really have 9 times Y. How would we write that?
9Y.
9Y. And it says if 9 times a number, or 9Y, and then it says is. What does is mean, class?
Equal.
Equals. So it says is, so class I put equals, and then it says, Corey, the sum of 8 and 19. Well, what does sum mean? So I should put,
8 plus 19.
there we go. So it says if 9 times a number is the sum of 8 and 19, what's the number? How many, first of all, had that equation that you wrote? Or maybe you said, well, I know the sum of 8 and 19 is 27, so maybe you actually started here. I would be okay if you started there as well, as long as you had one of these two equations written down. How many had one of those again? Hands, so I can kind of make a check. Okay, so almost all of you. The few that did it, does it make sense now? Do we follow now? So when it says a number or whatever the unknown is, just put some letter there. Now, it's one step, Corey. We just have to,
Divide by 9.
and we end up getting
3.
y equals 3. How many had that 3 was the number? You found that 3 was the number. All right, so you found that 3 was the number even though you didn't have the correct equation. Again, half the credit on a quiz or test. We're going to work toward getting that equation. Take a look at number 16. This one's fun. Read 16 for us, Griffin.
If 1/3 of a number is 11, what is the number?
And again, there's some number we don't know. So Ben, anytime there's a number we don't know, how do we represent it? Head offhand.
Letter.
A letter of some kind. Griffin, what letter did you choose?
B.
You chose B. All right, so Griffin, instead of a number, we're going to substitute B, okay? So it says if 1/3 of B is 11, what is the number, okay? 1/3 of B. Class, what does of mean?
Multiply.
Multiply. So to write 1/3 of B, Griffin, we would have to say
1/3 B.
1/3 B, because it's of and multiply up against each other. And it says is 11, class is means equals. So Griffin, we write
Equals 11.
equals 11. How many have this equation? 1/3 something, some letter equals 11. All right, questions on that equation. Now, Griffin, what do I got to do to solve for B?
Multiply 3 over 1.
Multiply by a 3 over 1. And what you do to one side,
You have to do the other.
so I'm going to multiply by 3 technically over 1, though if I didn't write it here, it's not so big of a deal. And I end up getting B is equal to
33.
33. How many had 33 is the number? All right, questions on 15 and 16. Yes, sir, Joel.
I did it differently.
What did you do?
Oh, never mind. I got it right.
Okay, all right, good. All right, questions on this. Any questions, comments? All right, man, some review equations, some nice refresher stuff there at the bottom, 17 to 22. Let's go over these answers quickly. Number 17, what did you get, Luciana? Z equals 7. Number 18, what did you get, Elaine?
H equals 10.
H equals 10. Number 19, Jalen, what you got?
Y equals -4.
Y equals -4. Great job. Number 20, Kirsten.
W equals -12.
Very good. W equals -12. Number 21, Ben.
M equals +11.
Oh, be careful, be careful. We've got an M positive 9 equals -2. Ben, I think I know what you did. What did you do to get the M by itself?
-9.
On both sides, right? Okay, so what I'm guessing, Ben, is you're like, wait, negative and negative gives you positive. And in addition, that's not true. In multiplication, it is. And yesterday we were working multiplication. So like, oh, the negatives cancel. In multiplication division, and those watching bear this review as well, in multiplication and division, negatives cancel. But when you're adding signed numbers, if the signs are the same, class, add and keep the sign, right? It's not like if I take $2 from Ben, I'm a thief, and I'm like, I'm going to take $9 more from Ben. Well, now it's a positive thing, right? So since I take money from him twice, it all works out. No, now he's really mad, okay? So no, if I take 2 and then I take 9 more, I have taken 11. Add and keep that sign. But yeah, so I could see the why we might think, oh, the negatives cancel. Be careful. Anyone else fall into that trap on 21, thinking negatives cancel? All right, be careful. Only multiplication and division. And then number 22, what did you get for that answer? Michael.
-5. What, 3? I have 2 answers.
He has 2 answers. I think, if I'm understanding what you had G -2 equals -5. Am I right? And that's where your -5 was. So we just want to make sure our work is written nice and neat. I think you combined the 9 and -14 to get -5, but you didn't write the G minus 2 equals part of it. But if we had, then we would see our one more step is to get the G by itself by putting a
A positive 2.
on both sides, and we get G equals.
-3.
Make sure your work is nice and neat. Now, I realize there's not a lot of room to work here in the book, which is one reason why maybe doing it on a separate paper would help, but try to be nice and neat and careful, show all those steps. Questions on the homework? Yes, sir, Joe?
20.
Number 20. I assume on the right-hand side you multiplied 4 times 3 to get 12, right? So your initial equation then was 24 plus W equals 12. What do we have to do to get the W by itself?
Is at -24.
Good. This is a positive 24. It's not multiplied, so we're going to divide 24. It's a positive 24. Good posture, Ben. We're going to put a -24 on both sides. And that's when, since the signs are different, we subtract, keep the sign of the greater. 24 minus 12 is 12, but keeping the sign of the greater gives us a -12. All right? Good. Other questions, comments on the homework? All right. Real quick, do the 26 to 31 in the review section. Take a moment to do the 26 to 31 there in the review section.
We already did it.
Yeah.
Oh, I'm sorry. Page 253. I can't read my notes. It has a different page number. My brain just assumed it's right above it. Page 253. 453. I can't read, okay? Page 453. Page 453. Review, numbers 26 to 31. The 26 to 31 threw me off because it was the same as the other review numbers. So I'm like, oh, it must be the same page. No, it would help if I would read my notes. Page 453. Do the review, 26 to 31. A little bit more practice there with forming equations, and then a little bit of a ratio practice as well. Been a little while since we've worked with those. Looks like Michael's finished. Just don't get all the ink all over your face. Griffin. Sienna's finished. Take about 30 seconds longer to finish up, and then we'll take a look at these classwork problems together. Good, Joel, Kirsten, Elaine. Yes.
Page 452, it says a gallon of gas in Hong Kong costs $7.86.
That's unfortunate. I bet that's actually accurate.
Where are you at?
He was looking at the little Hong Kong thing on the previous page. All right, let's take a look at the homework, or at this classwork together. Number 26, 12 more than a certain number is 32, and it asks what is the number. First of all, how would I write that equation? What did you have, Elaine?
X plus 12 equals negative 32.
Excellent. How many had some letter? It could have been X, could have been anything else. Plus 12, because more than also means flip it, equals 32. Did anyone have 12 plus some letter equals negative 32? You had it in this order here. Okay, that would have been correct technically as well, though I like this one because let's get us used to it. Anytime we see than, go ahead and flip it around. And so when you put a negative 12 on both sides, which I assume you did, Elaine, you got what for your number?
Negative 44.
How many then had negative 44 as the number? Okay, any questions on number 26? Any questions on 26? All right, number 27, the difference of a certain number and 62 is 23. What is the number? And Jalen, what was your equation?
J minus 62 equals 23.
J minus 62 equals 23. How many had this equation or whatever letter there? Good, because we know that difference class, the difference is the answer to a subtraction problem. So when we see difference, we know it means to subtract. From this point, then I assume, Jalen, you put a positive 62 on both sides to get J equals 85. How many had 85 as your answer then for number 27? Any questions on 26, 27, how to make an equation? All right, let's take a look at some ratios here. Number 28 says a store's display window had 4 t-shirts and 6 pairs of shoes. What's the ratio of t-shirts to pairs of shoes? Well, how do we write ratios? There's actually 3 different ways we can do it. Kirsten, let's see how many of these we remember.
The 2 dots.
We could use the 2 dots, so some number to some other number.
Or the fraction bar.
And this is the way that I actually prefer, is with a fraction, but there is one more way.
Or to just write 2.
Right, you could have a number and you could literally write the word 2 and then another one. This is how we'll read them in every case, but we'll often write them as a fraction. What was your answer then for number 28, the ratio of t-shirts to pairs of shoes? Kirsten?
2 to 3.
Good. Now notice she didn't say 4 to 6. She said 2 to 3. Why 2 to 3? Because class, we always reduce our ratios. How many also had 2 to 3 for number 28? What about number 29? Harold delivered 15 packages to homes, 8 packages to businesses, all while being chased by little gray bulldogs. And what did you get for your ratio of business packages to total packages? Griffin?
8 to 20, 23.
Excellent. We first had to figure out, well, what is the total package? We delivered 23, so 8 to 23. How many got that correct on number 29? How many fell into the trap and said 8 to 15? You just kind of didn't read it carefully. That's the kind of thing I would have done when I was in 7th grade and would have lost points and would have kicked myself for it and been frustrated. All right, number 30. Car wash had 10 customers with vans and 35 customers with cars. What's the ratio of cars to vans? What you got for this one? Joel?
72.
Good. 35 to 10, but he reduced by 5 to get 7 to 2. How many had that same answer on number 30? Should we write it as 3.5, class? No. Remember, ratios, we always just leave either as 7 to 2 or 7 to 2 or 7 to 2, but don't try to turn into some mixed number, right? We should just have the 2 parts. By the way, do you remember the name for the first number in the ratio?
Numerator?
Not the numerator. It starts with an A. It's also a term for pronouns. Antecedent. Yeah, the antecedent. You remember that from English class. And then what about the second number in the ratio, class?
Pronoun.
Consequent. The consequent pronoun. So consequent. All right. If you never mind. All right, number 31. Gonna pick on Michael there. Number 31. Patrick checked out 14 books, 14 fiction books, and 6 non-fiction books from the library last month. What is the ratio of fiction books to total books? What did you get for this one, Ben?
14 to 20.
14 to 20, but let's reduce by 2 to make it
7 to 10.
7 to 10. Excellent job. How many had that for? Number 31. All right, so a good review of ratios. Also want to review a little bit more with writing those equations. Questions on that classwork? Yes, sir.
Can you have a negative ratio?
You could. Generally, we compare stuff, and it's hard to have negative stuff. But if you were comparing like bank balances, and let's suppose you'd overdrafted, and so you had like, negative $10 in your bank account, and Joel had $20 in his bank account, then I guess technically we'd have a negative 1 to 2. You don't usually see that with ratios, though. Generally, if you're like, you don't see it very often, let's put it that way. A good question. Good. Other questions on the classwork? That was a well-thought question. Any others? All right. Flip back now, if you would, to page 446. Flip back to page 446. And let's take a look at the example problem here in the middle of the page. Again, we had 2 problems like these for homework last night. So this, not particularly difficult, but read the example problem for us, if you would, Bryson.
So which page again?
Page 446, the example problem in the middle of the page.
Alright. 3 times a certain number is 81, or negative 81. What is the number?
All right, now again, when it says a number, that's the unknown, so we're going to represent that class with a letter or with a variable. They chose x. Then you got to figure out, okay, what does times mean? Well, obviously, class, it means multiply, right? Multiplication. And of course, we remember, class, that is means equals. Very important to remember that. In general, your verbs mean equals. And so 3 times a certain number, 3x, equals negative 81. Gave them their equation, they divided by 3, they got negative 27. Questions on the example? All right, now let's give you a chance to try a few of these on your own. Flip over to page 448. Flip over to page 448 and do number 22 at the top of the page. Number 22 at the top of page 448. Write the equation and solve. Luciana, what's your equation?
2 fifths x equals 18.
How many had the similar equation? Maybe you used a different variable than x, but 2/5 x equals 18. And you have something different, you say, I thought mine was right. Can you tell me why mine isn't right? All right. What do we need to do to solve, Luciana?
We need to multiply the inverse.
Well, we don't call it the inverse. We have another name for it. It starts with an R.
Reciprocal.
Reciprocal. Multiply by the reciprocal, 5/2, and 5/2. And so we multiply, we get what?
X equals 45.
Good. Cancel, cancel, get x. Here, cancel, cancel to get a 9, so x equals 45. How many had 45 as your number? Questions on number 22. Number 23 at your seats. Number 23 at your seats. Write the equation and solve. Number 23. Write the equation and solve. Number 23. How would we write our equation? 3 times a number is 141. Ben?
3b times 41
Not times 141. What does is mean? So,
equals 41.
well, it's 141. 3b equals 141. How many had this equation, maybe with a different letter, but you had 3 times some letter equals 141? Then what do we need to do to solve?
cancel out the B?
Well, no, we don't want to lose the B. The B is what we're solving for. We wanted to say B equals. I don't want to get rid of the B. I want to get rid of the 3, right? So it's like if you've got if you had an annoying sibling, just imagine it for a minute. And then if you had an annoying sibling, you don't want to get rid of yourself. You want to get rid of them. You're cool with you. It's them that you're not cool with. We're not cool with the 3. How do we get rid of the 3 here, Ben?
You divided it,
Good. And what we do to one side?
you did the other.
There we go. Ben, how many times would 3 go into 14?
4,
With how many left over?
1,
What's 4 times 3?
12,
So how many left over? 2 left over. And then 3 goes into 21.
7.
7 times. How many had 47 as that number? Now we come to some that are a little bit more interesting. Number 24. Read that for us if you would, Jalen.
Harrison is half as old as his mother. If Harrison is 29, how old is his mother?
All right, class, do you see that there are 2 people in this discussion? We got Harrison and we got Mom. Or Mother. Speaking of Mom and Mother, don't forget that this upcoming Sunday is Mother's Day. You still have time to get candy, card, flowers, or at the very least, make something or do something special for your mother leading up to Mother's Day so that when you tell her you love her, she believes you. Okay, so don't forget this Sunday is Mother's Day. Make sure your mother feels loved and appreciated for all that she does for you. Give her a hug, unless she doesn't like to be hugged. I don't know what mom doesn't like to. Moms love hugs. Anyway, most mom. Never mind. I'm getting some people in. Okay. Anyway, so we got Harrison, we got Mom. One of these, class, we know what we need to know. One of these, we don't know, because she ain't telling. Class, we do know how old Harrison is. He is 29. That is not unknown. What we do not know is how old is Mom. And if we really loved her, or if he really loved her, he wouldn't be doing a word problem about her age. But we need to represent Mom's unknown age. How would we represent Mom's unknown age? Anyone? M? Okay, we could represent it M. All right, now, when we look at the first sentence compares the 2 people to each other. Read that first sentence again for us, Jalen.
Harrison is half as old as his mother.
At his mother? As his mother. Harrison is half as old as his mother. All right, so class, what we are going to do, we're literally going to represent exactly what it says. It says Harrison. Well, class, I know what Harrison is, so instead of the word Harrison, class, we can write 29, because we know he's 29. And then it says is, so class, equals. And then it says half as old, so that means I need to put a, what, half, but half as old as who? As Mom, so I need to put M. And literally, there's my equation. Do we see how to represent one of these? You identify the people in the discussion, the one you know, the one you don't know, pick a letter. All right? Now, if Harrison, 29, is equals half as old as Mom, well, that's half of M. And so what would we need to do to get M by itself, class? By, which is 2 over 1, 2 ones, or 2 over 1. Do I have to write the 1 on this side?
No.
Not really. I could if I wanted to. The important thing is everything cancels on here to just get M, and over here,
58.
Mom's still 29. She just, that's what she's claiming. But anyway, she's actually 58. This is the 29th anniversary of her 29th birthday. And so, anyway, questions on number 24. Questions on 24. All right, read number 25. Michael. Oh, you have a question?
Yeah. Personally, as you, just as a math teacher, would you have like wrote an equation for that, or would you have just like that did it in your head, like 29 plus 29?
Well, since the point was to write the equation, obviously we would do that. I don't mind if you can do it quicker in your head, so you already know how it's going to turn out. And then the nice thing about knowing what it's going to sound like, oh, if it's half as old as Mom, well, he's 29, add another 29 is 58. So if you already know what the answer is going to be, then when you set up your equation and solve, if you got something different, you're like, well, that equation must be wrong. Then what did I do wrong? Why am I getting that Mom is 14 and a half? That's a really young mom to have a 29-year-old kid. You know what I'm saying? Like, this family tree is really jacked up. You know what I'm saying? So Michael, yeah, it's not a bad thing if you can solve it in your head ahead of time, but I have to see the equation and then the answer. So, but use that as a way of checking, right? Especially if you can do it in your head. Yes, ma'am.
Okay, so what I did was
29 times 2 equals J.
Yeah, that's what we did. Well, 29 times 2. Now, here's the problem. That's how we solved it, right? That's how we solved it. But ultimately, the equation is what the problem said to write out. Does that make sense?
I didn't have a half in there.
No, but you should have, because the word problem had a half in it. Does that make sense? Harrison is half as old as his mom. So if it's in the problem, it needs to be in the equation. Now, we end up multiplying by 2, right? So we ended up doing what you did, but the initial representation needs to reflect what the problem actually says. Does that make sense? So as far as, again, if you got the 58, okay, you get credit for that. You just didn't have the correct equation to start, so that's where you'd lose some credit. Does that make sense? All right, look at number 25. Now read that for us, Michael.
McKenna?
Sure.
Okay. Donated 32% of the money she earned babysitting to the local mission. Her total donation was $14.24. How much did she earn babysitting?
All right. So we have really two things that are kind of being discussed here. We have the question, how much did she earn? But we also have some other amount of money that's referenced, class. Her donation, right? So we have her earnings from her babysitting, and we also have her donation that she gave. Now, the donation we know, right? The donation, it says, class, is
$14.24.
which is a really random donation. One more penny, like $14.25 wouldn't seem so random. Or round it up to the nearest dollar for charity, $15. No, $14.24. But we don't know how much she earned. So, class, we could represent her earnings. E. Why not? Okay. E. So now later, EA Sports is in the A. You'll learn later why we won't use E very often in algebra, but for now we'll go ahead and use it. And it says she donated. Her donation was, now it doesn't, yeah, there it says donation was $14.24, but this donation was 32% of her earnings. Do we see that in the first sentence? Her donation was 32% of her earnings. Well, we know the donation, class. And it was. Now, that's not the same word as is, but it's roughly equivalent, right? It's the past tense. So was, class, is also going to mean
Equal.
her donation was 32% of her earnings. Well, what does of mean?
Multiply.
So we need to multiply 32% times her earnings. That's 32% times E? Well, do we ever multiply percents, class?
No.
We always change them to
Decimals.
So we'll make this
0.32.
0.32. Now, how do we get the E, her earnings, by itself?
Divide 32.
Divide the 0.32. Right? Do we see the point? It was of, right? 32% of. So if it's being multiplied, we've got to divide. But what we do to one side, gotta do. Wait a second. Are you allowed to divide by a decimal?
No.
So you know what we gotta do? But if we do it in the bottom, in the top as well. So we end up dividing here. I'm going to set it up as a long division problem. 1,424 divided by 32. How many times does 3 go into 14, class?
4.
4. 4 times 2?
8.
4 times 3?
12.
Let's subtract. We get
14.
14. There we go. Bring down the 4. How many times 3 go into 4? 14?
5.
4 times. And 4 times 32 was just 128 a minute ago, wasn't it? So that means it's 128 again. What do we get when we subtract?
14.
No,
Wait,
no.
16.
16, thank you. Oh, I'm still not done. Let's put a 0 and a decimal. Let's bring it down here. How many times does 3 go into 16?
5.
5 times. 5 times 0.
2.
10. Carry the 1. 5 times 3 plus 1?
16.
So how much did she earn, class? 44.5. Wait, 44.5. What does that mean? $44.50. Questions on this? By the way, next year in pre-algebra, when you talk about percent problems, every percent problem you do, you're not going to have to remember when do I multiply, when do I divide. Next year, you're going to set them all up as equations. That's how I'm going to start off teaching. I'm going to use what we just talked about through here, and you're just going to make equations, remembering that of means multiply and is means equals, and it's going to take all the thought out of those problems. Look at page 449 now, if you would, please. Page 449. We are going to step up our equations just a little bit. Yes, and instead of only one step to solving the equation, instead of one step to get the letter by itself, it's going to take 2 steps now. Here's the rule of thumb, if you want to write this down at the top of the page. When you get a letter by itself, for instance, look at the very top of the page, that little tiny blue box there. It says 2a plus 4 equals 10. Okay? Notice that there are two things with the a. There are two annoying little siblings, right? They both got to go. What two numbers do I have to get rid of, class, to get the a by itself?
2 and 4.
The 2 and 4. Do we all see the 10 is cool? We're cool with the 10. It's in another room. We're fine. The 2 and the 4 got to go. Here's the key. Write this down. Get rid of the least attached thing first. Get rid of the least attached thing first. Get rid of the least attached thing first. Now, your parents did this when you were little, and you had all these little baby toys and stuff. How many of you, when you were little, you remember having that little stack of plastic donuts? There was like the big blue donut, the green, the colored donuts. Let's be real. Has any kid ever in the history of kids really actually played with those things? They make a mess. They scatter them around the room. The parents try to teach them how to roll them or something, or stack them in the right order. And the kid just like bites on them a little bit and wanders off after scattering and leaving a mess for the parents to clean up, okay? So the parents, as you got older, your parents, those of you who had a little stacking donuts, be like, yeah, these can go. You didn't play with them. How many of you had a special blanket or stuffed animal or pillow? Everyone in here had one of those things. How many of you still have that blanket, stuffed animal, or pillow? Many hands are still up. Bryson's like, no, mine's gone. Okay. At some point, though, you understand as you become an adult, right? And put away childish things, the Bible says. At some point, Pookie has to go, or whatever you call your stuffed animal, or the baby blanket's got to go. At some point, you gotta grow up, right? It's gotta happen. And so, but here's the thing: your parents haven't gotten rid of this yet because you're so attached to it. As we look at the A right here, one of the two things we have to get rid of, class, is really attached to the A, or the A is really attached to it. What is the A attached to, class?
2.
The 2. It's not attached to the 4. So that means we can go and get rid of the 4, because it's not attached anyway. How do we get rid of the 4, class? Negative 4. On
Both sides.
both sides. And that cancels away. Now we've got a 2A equals 6. But now it's time for the A to grow up. And the blanket has got to go. We've got to get rid of the 2. I know the A is attached to it, but this is for your own good, little A. And so we got to get rid of the 2, class. Divide. This is a depressing class. Y'all are like going to go out of here crying. You show up to Bible, everyone's in a somber mood. What's wrong? You said we have to get rid. Anyway, so anyway, we're left with A is equal, class, to 3. And there's our answer. Look at the next example problem in the blue shaded box. We got a y over 7 plus 3 equals 4 plus 1. Well, remember, we always simplify what we can. 4 plus 1, class, let's just make that a 5. It's annoying that it wasn't already a 5. Anyway, so that gives us y 7 plus 3 equals 5. Now, there are 2 numbers that have to go. What 2 numbers must I get rid of, Ben?
The 7 and the 3.
But which one is kind of attached to the y?
7.
The 7. The 3 ain't, so let's just get rid of the 3, class.
Negative.
Negative 3. On both sides. And that's going to give us a y 7 equals 2. But now, time to become a man. We've got to get rid of that 7. Yeah, I know you're attached to it, son, but we're not a little boy anymore. Let's man up. Come on now. And so we got to get rid of the 7. How do we get rid of the 7, class? Multiply, because it's being divided. And so that cancels to give us y equals 14. Do we see the 2-step approach here? As long as you get rid of the thing that's least attached first, you're going to be all right. Look at letter B, though. This is kind of interesting. We got a 3x plus 2x minus 9 equals 6. Well, here, I got 2 different x's. This time, instead of simplifying the 4 plus 1 over on the other side, I actually have to simplify these 2. Because you can't have 2 different x's you're solving for, right? Solve for x. Which one? Okay, you got to combine them together. So class 3x plus 2x, 5x. Okay, now we're ready to get the x by itself. Does that make sense? You can't get the x by itself if there's 2 of them. They got to combine. Now we get the x by itself. What 2 numbers have to go, Griffin?
5 and 9.
The 5 and the negative 9, technically. Which one do I get rid of first?
The negative 9.
Class, I get rid of the negative 9 because it is less attached. It's not attached to, right? So we get rid of the negative 9, Griffin, by putting a
Positive 5. I mean 9.
9 on both sides to get a 5x equals
6. No, not 15.
15. There we go. And now the stuffed animal's got to go. Bye-bye, Stuffy. How do we get rid of the 5, class?
Divide.
Divide it away on both sides, and that's going to give us x equals
3.
3. Do we see how to solve equations like
My
these?
brain.
It hurts your brain.
No, I'm just saying how.
Oh, the thought of giving up your Stuffy hurts your
No,
brain.
I just kept on messing it up there.
All right, turn over to page 451. Flip over to page 451. And let's just do the first 6 problems together, or at your seats. Do just the first 6 problems on page 451. Getting the letter by itself. Check your answers to the first 6 problems. How many got all the ones you did of these? Even if you didn't get all 6 done, all the ones you did, you got right. All the ones you did were correct. All right, any questions on these? I showed all the steps, so you should be able to see what you did wrong if you missed one. But are there any questions on numbers 1 through 6? All right, we didn't practice as many of these today as I would have liked. We'll do some more practice tomorrow. You'll also do some practice in your homework tonight. So do your best with the homework. Again, I would encourage you, do it on separate paper. There is not room to do all these steps right there in your book in that homework section. So I would strongly encourage you, do it on separate paper. For homework, page 453. Page 453, the homework section, do 1 through 18. Page 453 in the homework section, 1 through 18. We'll take a look at all of this tomorrow as we do more practice with equations and word problems tomorrow. Have a wonderful rest of your day, and when the bell rings, you'll be dismissed.
I'm gonna go with the